Okay, problem number 1 on the study guide. Selfie walked for a while at 3 miles per hour, then jogged the rest of the way at 9 miles per hour. So she's covering a certain distance, specifically 57 miles, in 2 parts. So she walked for a while, so let's say that this represents her walking. It doesn't tell us how far she walked, so we're going to establish that as a variable. Then she jogged the rest of the way, so from that point she started jogging to finish the trip. So altogether, she covered 57 miles. So by the picture, we can see that her walking distance, adding to her jogging distance, is going to equal her total distance. That's priority 1 on the test. Selfie's going to be walking and jogging, covering a certain amount of distance. So a similar type of relationship should happen on the test. Now, in this case, we're going to have categories of walking and jogging. My next responsibility in this problem is to establish the rates and times of each specific instance. So it says she walked at 3 miles per hour, she jogged at 9 miles per hour, so we know her specific speeds of both walking and jogging. And it does say that she covered all this distance in 9 hours, but it doesn't specify how much was spent either walking or jogging, but together is 9 hours. So that's the total time. Anytime we know total time, we let one of the times be t, the other is going to be the total time minus t. It's how you always do it. So always make an understanding in your problems if it's a total time issue. That's how you handle it. I could have just easily made this t and that 9 minus t. It doesn't matter which is which. But once I make a decision now, t is her walking time, 9 minus t is her jogging time. So rate times time is distance, so 3t would be her walking distance. This is a binomial times 9 is going to be 81 minus 9t. That's her jogging distance. And her walking distance plus her jogging distance is equal to 57. So at this point, I take those two expressions. 3t is her walking distance. 81 minus 9t is her jogging distance equals 57. So this equation, there's dw plus, and then dj is both of these objects, equals 57. Move the 81 to the other side, so that makes 3t minus 9t is negative 6t. 57 minus 81 is negative 24. And then 24 divided by 6 is equal to 4. They're both negative, so you get a positive. T is equal to 4 hours. Okay, and again, going back to my chart, t represents her walking time. The question does not ask for how long did she walk. The question says how far did she walk. So we're looking for her walking distance. So their distance walking is going to be 3 times 4, which is 12 miles. Keep in mind in these problems there's always things you don't know. Every variable here represents something you don't know. That's something they might ask you to find. The equation doesn't always answer the question they're asking. If they ask for her walking time, we're done. If they ask for her jogging time, 9 minus 4 is 5 hours would be her jogging time. If they ask for her jogging distance, 81 minus 36 is equal to 45 miles. So again, there's 4 different possible answers to this problem. This is not necessarily the answer to the problem, so be careful you do go on to answer the question they're asking for in the problem. Number 2, Johnny found the large ones totaled 30 more than 3 times the number of small ones. The ratio of number of small ones to large ones was 1 to 5. How many were large? So we have large ones and small ones. Okay, and that's 2 different variables. So if I say L equals large and S equals small, and if I look at the words that create equations, the large ones L totaled equals 30 more than, we don't care about till the end, 3 times the number of small ones, that's 3s. Is 30 more than, so 30 more than happens after the equal sign, so plus 30 is fixed in the right-hand side. That'd be equation 1. The other equation, they use the word ratio, and a lot of times we see ratio, we think about making this chart for ratios. When they start saying something along these lines, when there's less specific, like if it says the ratio of ducks to pigs in the barnyard or whatever, they go ahead and make that chart. But ratio of small to large, it's not as obvious. They're not telling me how many large or small are happening. Like in those ones where we make the chart, they usually tell us how many pigs or whatever are in the barnyard. So in this case, the ratio of small to large, that's S over L. That's what a ratio is, just a fraction. The ratio of the small on top to the large on bottom was equals 1 to 5. So you can create a ratio equation like this. If I cross multiply, I'm going to get L equals 5s. Right? And that would be the better way to do it in this situation. So now I get two equations, two unknowns. L equals 5s, so this is a substitution value I can put in for that L. So the blue equation becomes 5s instead of L equals 3s plus 30. So there's the exact equation. L changed to this, equals, stays equals, 3s stays 3s plus 30 stays plus 30. Move the 3s over, we get 2s equals 30. Divide by 2, we get s equals 15, and that's 15 small ones. It says how many were large. We just found out how many were small. Okay? To find out large, L equals 5 times s, so L equals 5 times 15. So that gets me 75 large ones. And that is the answer to the question they're asking. So again, first two problems, they do ask specific questions, answer the questions they're asking. Number 3, Zolli noted 7 grams of magnesium combined with 23 grams of other elements to form the compound. 1,260 grams of the compound were required. How many grams of other elements were required? So we're trying to form a compound. The ingredients of the compound are magnesium and other elements. So the first job in this problem is to establish the recipe, basically, for this. So magnesium and other elements are combined together to make some compound. And the recipe that they give us represents the ratio of things. And then we have actual amount of what we want. So, Zolli noted 7 grams of magnesium were combined with 23 grams of other elements. Okay, so these are the recipes, these are the pieces that go into the recipe. They add up to the total weight of the compound. So that's one recipe, like one serving basically of this compound. 7 grams of magnesium with 23 grams of other elements makes 30 grams of the compound. I know that because these add up to 30. 1,260 grams of the compound were required. So now we move on to actual numbers. This is how much was required. This is how much Zolli made at her initial experiment. So 1,260 is what is actually needed. And how many grams of other elements were required? That's what they're asking us for. They don't care about magnesium. They must have enough magnesium. They want to make sure they have enough other elements to do this. So we get 23 over 30 is equal to x over 1260. As with all ratios and proportions can be reduced vertically if those numbers have a common factor, which they don't, or horizontally if those have a common factor, which they do. Obviously 10. And if you want to go even further, 3 goes into 3 and 3 goes into 126. So that would be the best plan there. 1 times x equals x, and 23 times 42. We get 966 grams of other elements. Number 4, simplify. These problems, I think 5 is the same way if I remember right. Yep. Yeah, just 4 and 5 are the same. These problems have an expected thing to happen, which is when you fix the fact there's radicals in the denominator, the radicals should match, so then addition of the fractions is possible. So expect this answer to be just something times the square root of something over something. That's what you're looking for, this basic structure here for your final answer. Some number times the square root of some number equals some number. That's what you're looking for as a finished product of this problem. The first step in this problem is to break apart the fractions. So the square root of 2 over the square root of 5 plus, actually, I'm going to leave a little space here, plus, and then same deal here, I've got the square root of 5 over the square root of 2. So that's priority 1. Break it apart into simpler problems. And the issue in each case is the radical in the denominator. We don't want that happening. So multiply by the square root of 5 gets rid of the square root of 5. Fraction world though, multiply the bottom by something, you got to multiply the top times the same thing. So the end result of this term is on top, I've got a 2 and a 5 inside the radical that multiply to make a 10, a square root of 5 and a square root of 5 on the bottom, which make 5. That's as simple as that black term can get. The 10 and the 5 can't reduce because this 10 is inside a radical, that 5 is not. And keep in mind again, when you multiply a radical times itself, you simply drop the radical. Square root of 5 times the square root of 5 is equal to the square root of 25, which equals 5. So in general, you match a radical, you get the non-radical version of it out. The second fraction, the problem is the square root of 2 on the denominator, so multiplying by the square root of 2 is going to fix that. If I multiply the bottom of a fraction, I'm going to multiply the top of the fraction also. So on top, I got a square root of 5 and a square root of 2, which make a square root of 10. On the bottom, the square root of 2 times the square root of 2 makes 2. Once again, I can't reduce that because that's inside, that's outside. And once again, that's as simple as I can possibly get that fraction. This is what you should expect to happen after you do your fixing. So once you've got the bottoms fixed correctly, the radical should be the same radical piece. That should happen every time, which allows us then to add these fractions together. This is 1 times the square root of 10 over 5. This is 1 times the square root of 10 over 2. What I'm actually adding here is going to be this fraction and this fraction. So the square roots of 10 are basically protected in this. So when I make this common denominator of 10, for the first fraction, this is 5, it needs a times 2 on it to make the 10 we want, so I have to do a times 2 on top to make the same thing happen, just like I did here. If I multiply the bottom, I've got to multiply the top. I need this doubled to make 10, so I have to double that also, so I'm going to get 2 times the square root of 10 out of that. Same deal here, this is 2 on the bottom, I need it to be 10, it has to be multiplied by 5, so if I multiply that times 5, I've got to multiply the top times 5. 5 times 1 is 5, so we get 5 times the square root of 10. So altogether, the final answer here, 2 square roots of 10 plus 5 square roots of 10 makes 7 times the square root of 10, all over 10. Creating that structure I'm looking for, something times the square root of something over something, that's what we're looking for in a final answer. The only other thing you could possibly do to a problem like this, if possible, is if that fraction happens to reduce, you should reduce it. Obviously 7/10 doesn't. It's tempting to say those are both 10, but again, that's inside, that's outside. You cannot interact those two numbers. The only numbers that will interact will be these numbers. That doesn't reduce, that's the best you can do. Number 5, same level problem. The only difference is we have these whole numbers in front, and all that's going to do to us is for this first term, it's going to put a 4 on top of the square root of 2. So that 4 that's out in front is a whole number, so it belongs in the numerator. And then the same thing here, that 5 belongs in the numerator. And again, I'm leaving myself some space here because I'm anticipating multiplying top and bottom here. So minus 5 times the square root of 5 on top over the square root of 2 on the bottom. The fix for this is the square root of 5. Top and bottom must be multiplied by the same number. The fix here is the square root of 2, so multiply top and bottom by the same number. This ends up getting me 4 times the square root of 10 on top. This is outside the radical, these are inside, they multiply inside a radical. Square root of 5 times itself is 5. This times this. 5 is outside the radical, it stays outside. Square root of 5 and square root of 2 make the square root of 10. And the square root of 2 times itself makes 2 on the bottom. Once again, we're in a situation, common denominator is 10. Make that common denominator of 10. This needs a times 2, so this needs a times 2. This needs a times 5, so this needs a times 5. In each case, we're making the 10 we want, but we have to modify the numerators appropriately. So the black one becomes 8 times the square root of 10. And the green one becomes minus 25 times the square root of 10. And the final step, as before, we add or subtract the top based on the signs. Plus, minus, subtract. Whatever the square root part is stays the same. 25 is bigger than 8, so it's negative, and that goes over 10. Once again, look to see if that outside fraction, not counting the radical, reduces. It doesn't. Leave it like that. Do leave it in improper fraction form. Don't make some mixed number answer. Just that's the proper way to write the answer on that. Number 6, each of the 4 squares is equal in area. The area of the square is 144 square meters. So let's start with that fact. The area of this square is 144 meters squared, and I know that if this is the length of the side of the square, that side's the same. Length times width, which would be x squared, has to equal the given area of 144. So obviously x is going to equal the square root of 144, better known as 12. That's meters. Okay, so that's priority one. Figure out how long each side of the square is. Okay, once we know that information, it says what's the area of one circle. Now the other piece of information that they tell us that seems kind of unnecessary maybe, but it's important. Each of the four circles is equal in area. All that tells me is the radius of each circle is the same. So what I know for a fact is that this radius here is the same length as this radius here. And I know that in the world of circles that the radius is the same in all directions, so if it's that far to that side, we'll call that R to give it a name. And I know for a fact that this distance here is also going to be R. Obviously these circles have the same radius because they have the same area, so this is also equal to R. And finally, this is also equal to R. So looking at the picture, I have a total of 1, 2, 3, 4 R's straight across that figure, and this length should equal the same as that length. So I know that 4R has to equal 12, which means R is equal to 3 meters. So just like that, I figured out the radius of the circle. Okay? And that leads me to the question they're asking me, which says, what is the area of one circle? The only way I can answer that question is to find out what the radius of that circle is, and that's how you go about finding the radius. You figure out how long the side of the square is. There's a total of 4 radii across that are all equal to each other that have to make the same length as that. That makes the radius equal to 3 meters. So the area of one circle is going to be pi times the radius squared. If we go with 3.14 approximating pi, that's 28.26 square meters would be the area of one circle. Number 7, find an equation in the line. Okay, let's focus first on the words, the directions. Find the equation in the line. Our job here is to find an equation, y equals mx plus b structure. It passes through a point, that's helpful, so that's going to be necessary information at some point in this problem. And it's perpendicular to a given line. Okay, let's focus on the perpendicular to the line first. Anytime I see what's highlighted in blue, find the equation line, my first priority is how do I find the slope? What information they give me that helps me find a slope. In this case, what's highlighted in green helps me find slope. If y equals 5x minus 7, the slope of this line is equal to 5. The number in front of x is always the slope. Okay, if I write that as a fraction, that's 5 over 1. Okay, we always like slope as fractions. Now, the key word here is it says perpendicular to. Okay, if it's perpendicular to, this perpendicular slope is going to be the opposite side reciprocal of the actual slope of the line they gave me. So the blue line is what they gave me. The blue line has a slope of 5 over 1. The perpendicular line is what I want. The perpendicular slope is, again, the reciprocal of the fraction, 1/5, and the opposite sign, positive, changes to negative. This is the slope I need in order to find what I'm looking for. And once I know the perpendicular slope, I would throw this completely out, scribble it out, something. So I don't think that's important anymore because it isn't. Okay? Once I get to my slope, now I'm going to focus on the slope I know for the line I care about, my perpendicular line, along with the point of intersection, 10, 2. That's what the line passes through. 10 is x, 2 is y, this is m, and we know y equals mx plus b is our structure. So I'm going to substitute y there, I'm going to substitute x there, and I'm going to substitute m right there. So I do all that substitution. Y is 2, m is negative 1/5, x is 10, and b is what we don't know. Negative 1/5 times 10, 10 divided by 5 is 2, times negative 1 is negative 2. And if 2 equals negative 2 plus b, we move that 2 over, it becomes positive. 2 plus 2 is 4. So b is equal to positive 4. So once I know both the slope, the perpendicular slope, and the y-intercept 4, my answer is y equals negative 1/5 x plus 4. Make sure the x shows up in your answer, make sure the y shows up in your answer, make sure the x is in the numerator of that fraction, doesn't show up in the denominator. If you have it like right beside it, y equals negative 1/5 x plus 4, that's also fine. Y equals negative 1 over 5x plus 4 is wrong. Okay, so x either off to the side or up on top. I always put it on top just to be safe, but I've seen a lot of you forget to put it completely. So if you put this, forget the x, that's wrong. So make sure on your test that you pay close attention to detail on the final answer on finding the equation line. Your equation should look like that. Number 8, simplify 0.0056 times 10 to the 19th. Let's start with that one. Okay, if I change that into good scientific notation, 5.6, the decimal point belongs right there. To make it get where it belongs, 1, 2, 3 spaces moved, and it became a bigger number. So I have to make this a 3 smaller number. 19 minus 3 is equal to 16. The second one, 0.003 times 10 to the 8th. I want the decimal point right there. That makes 3. And 1, 2, 3 spaces bigger number, so 3 smaller than 8 is 5. And on the bottom, we have 7,000. I want the decimal point right there. That makes 7 times 10. I made that 3, moved over, and it became a smaller number. 3 smaller, that has become 3 bigger. 8 plus 3 is 11. So priority 1 right there, do exactly what I did. Get every number to good scientific notation. Next, we're going to multiply the stuff on top together. 5.6 times 3 makes 16.8. And then for the powers of 10, I'm going to add them together. We've got a positive 16 and a positive 5 make positive 21. Now, we can see on top, this is not good scientific notation, but we do want the answer to be between 1 and 10. And 7 divided by 7 would be 1. 70 divided by 7 is 10. The fact that 16.8 is between 7 and 70 means that's probably in better shape, just to leave it as 16.8. So, to get the final answer, I'm going to divide the front numbers. So I'm dividing 16.8 by 7. Decimal point goes right there. 7 goes into 16 twice. Subtract, you get 28. 7 goes into 28 4 times. Get remainder 0. So 2.4 is the quotient. And I've said this like 50 times now. I'm going to say it one more time. Write down the subtraction problem. You take the top power minus the bottom power. Look at that subtraction problem to establish the power of 10 you're supposed to get. 21 minus 10 is 10. Okay. Write it down so you can actually look at it. If I'll just show you what the main issue is. And if I have, and that's the end, of course, that's the answer to that. But if I have like 4 times 10 to the negative third over 2 times 10 to the negative 11th, and I'm trying to do that one, 4 divided by 2 is 2. If I try to do negative 3 minus negative 11 in my head without looking at it, I might do something wrong. So if I write it down, negative 3 minus negative 11, that actually becomes negative 3 plus 11 because the 2 minuses make a plus. Look at it in a simpler form to determine should I add or subtract. The signs are different, so I subtract. 11 is bigger, so it's positive. So make sure you consider it that way when you're doing it. Number 9, simplify 6 squared of 80 minus 3 squared of 45 plus 2 squared of 20. Addition and subtraction of radicals is only possible if the radicals match. These obviously don't match, so at this current state it's not possible. But the numbers 80 and 45 and 20 can all be factored, and by factoring we might be able to reduce them down to something more manageable. So if we start with 80, is 2 times 2 times 2 times 2 times 5. If you want to be sure that you have a correct factored form for something, it's real easy. You take your calculator. First of all, they should all be prime numbers. And you take your calculator, type in exactly what you have written there. 2 times 2 times 2 times 2 times 5. It should equal the number it's supposed to be, which is 80. So that's a good factored form of that. Looking at that, a pair of 2's, I get to pull a 2 out. I got a second pair of 2's, I get to pull a second 2 out. I've got a single 5, I can't pull that out. Anything I pull out is going to be multiplied by what's already out there. So there's already 6 out there. The 2's that came out multiplied by the 6. The second term is minus 3, so I'm going to write minus. I'm going to leave myself some space because, again, I'm assuming that some stuff's going to be able to be pulled out. If we factored 45, we're going to get 3 times 3 times 5. And again, if I want to verify that, obviously 3 and 5 are both primes. 3 times 3 times 5 equals 45. That's the correct factored form. And we can see very clearly there's a pair of 3s, so I can pull a 3 out. Finally, my last object is 2 times the square root of 20. So I'm going to put plus, and again, leave some space, 2 times the square root of 20. 20 is 2 times 5. And again, if I want to verify that, be sure, obviously, 2 is a prime number. 2 times 2 times 5, if 5 is already a prime number we've established, multiply, we get 20. So what I have is a pair of 2s, I can pull 1, 2 out. 5 has to stay in. So the the blue 6, the black 3, and the red 2 were all part of the expression already. The green 2, the green 3, the green 2, and the red 2 all came out because of the pairs of factors inside. Altogether, this thing becomes 2 times 2 times 6, which is 24 times the square root of 5. This thing becomes minus 9 times the square root of 5. And this one becomes plus 4 times the square root of 5. Okay, and now they're all the square root of 5, so now addition and subtraction is legal. 24 plus 4 is 28, minus 9 is going to be 19 times the square root of 5. Okay. Expect the one on the test to be similar in the fact that all 3 of them come out with the same radical piece. If 2 of them did and 1 didn't, let's say this is square root of 5, square root of 5, square root of 3, those 2 would make something new, then the square root of 3 object would be off to the side as a separate object. Number 10. Now we're multiplying a radical object times another radical object in distributive property form. So that 2 square root of 3 outside multiplies evenly through the parentheses. 2 square root of 15 and 6 square root of 5 get multiplied by that 2 square root of 3. So when I do the black multiplication, multiply the numbers on the outside. So 2 is going to multiply by 2 to make 4. But instead of doing 3 times 15 is 45, 3 is already prime, 15 is 3 times 5. So there's the 3 and there's the 15. So finish factoring it out. So we have the ability to do just like the last problem. If we have a pair of factors like we do here, we have a pair of 3's, I can pull a 3 out, just like so. The 5 can't be pulled out, so it's going to stay in. When I do the red multiplication, outside 2 times negative 6 makes negative 12, leaving myself a little gap there in case I can pull anything out. And then I've got to multiply 3, which is the radical piece of this, times 5, the radical piece of that. Those are both primes, so I can't make them any better than that. 3 times 5. So again, that's factored form. Notice in this one, there is no common pair. 3 is 3, 5 is 5. They're different. Can't pull anything out. So I can't make that any prettier than what it is. This, I, of course, took the 3 out, making it prettier than what it is. So my final result is the simplified version of each term. So term 1, outside is 3 times 4, which is 12. Inside is 5. The second one, the outside number is 12. It's just a single number. Inside, 3 times 5 is 15. These are not the same radical piece, so subtraction is illegal. So that's as far as I can possibly go with that one. And I would expect you to get to that point. So if, for example, you gave me 4 times the square root of 45 minus 12 square root of 15, that's not good enough. So you need to make sure that you break it down as far as you possibly can. So can't make 5 any prettier, can't make 15 any prettier with radicals because there's no pairs. You can't subtract because the numbers are different in the radicals, so that's as far as you can possibly go on that problem. I'd expect the one on the test to work similarly to that point. Number 11, factor completely. First thing I noticed about this is it's cubic. Okay, so if it's cubic, I'm expecting x to be a common factor. We can see very clearly x is a common factor. The other thing I notice is my lead term is negative, which I don't ever like. I like my lead term to be positive. I also notice there's 3 in the lead term. I never want the lead term to be anything but 1. So 3 goes into 3, 21, and 30. So obviously 3x is a common factor. And again, I want to make it a negative 3x because I want the first term to be positive. Okay, so find the common factor, and again, make it negative because the first term is negative. So now when I divide, I'm dividing by a negative number. Negative 3 divided by negative 3 is 1. X cubed divided by x is x squared. So 1x squared is my friend in factoring. So if I can get 1x squared, that's helpful. 21 divided by negative 3 is negative 7. X squared divided by x is x. Negative 30 divided by negative 3 is positive 3. And x divided by x, oh sorry, positive 3, positive 10. Negative 30 divided by negative 3 is positive 10. X divided by x cancels. So just like that, I take this negative 3x out. I'm left with a quadratic trinomial. So that's step 1 of factoring completely. Step 2 is to actually factor this again. As long as we have x to a power bigger than 1, we have to consider that might factor more. So x squared, this might factor more. So if we focus just on this red underline here, and look at a possible factor form of it, we're looking for product of positive 10. It also adds to make negative 7, and negative 2 and negative 5 do the trick. These multiply to make a positive 10, they add to make a negative 7. X is the letter that's in the problem, so x minus 2 times x minus 5 is how that factors. And then of course our negative 3x common factor is still part of the answer. So that is factored completely. Once each factor is x to the first power, x to the first, x to the first, x to the first, that's when you're done factoring. Don't stop until you get to that point. On the test, it will be factorable to that level. So whatever quadratic you're left with should factor. If it doesn't, chances are you did something like I did and wrote a 3 instead of a 10 there. That wouldn't factor. So just be careful in the pulling out of the common factor that you get yourself the correct quadratic, and that quadratic is going to factor just like they all have so far. Number 12, same idea, factor completely. This time we have 3 letters, x, y, and z, but if you focus just on the x squared, x to the first, no x at all, yz, yz, yz. The yz is a common factor. So as far as descending order is concerned, this is the highest power of x, that'll go first. This is the next highest power of x, that'll go second, and this is the lowest power of x, there isn't one. So first thing I do is rewrite this one in correct order. So x squared yz first, plus 5xyz second, minus 24yz last. And looking at the common factor, yz belongs to everything. 24, 5, and 1 don't have a common factor. My highest power term is positive, so when I take out the common factor of yz, I'm going to let it be a positive yz. That way the signs stay what they are, keeping me a positive x squared. And then of course plus 5x and then minus 24. And just like the last problem, this is a quadratic trinomial. We have to expect that's going to factor again. 8 and negative 3 multiply to make a negative 24. 8 and negative 3 add to make a positive 5. So this black underline factors to x plus 8 times x minus 3. And this y and z common factor is part of the answer. It's going to go out in front. Okay, each of those problems should work just like that on the test. There might be some rearrangements necessary. Number 11 had a negative common factor because the highest power was negative. We wanted it to be positive. Number 12's highest power was positive. We took out a positive. That type of stuff is going to happen on at least one of the problems. So look for the possibility of a negative or a positive common factor. Then again, the quadratic should factor beyond that. Number 13, solve this. And this is a problem that a lot of you have been having on homework. I want to really highlight where the issue is. We all know to multiply by 10. I don't think anybody is having difficulty with that part. And I want to focus on the multiplication part of this to make sure we see where things are coming from. So if I multiply this here, 4x over 5 times 10. 10 divided by 5 is 2 times 4x is 8x. Nobody's having an issue with that. It's the second one people have an issue with, this one here. All right, 10 divided by 2 is 5. That's being multiplied by 5x plus 2. What I want you to see is that minus sign that's right there is attached to the quotient that's being distributed through here. And the other thing we might have done before we even did this, might have done 4x over 5 minus 5x over 2 minus 2 over 2 equals 33. We might have split this apart into 2. This minus sign is minus this and minus that. Minus a positive makes minus, so this term here is negative. If you wanted to go this route, that's fine, but here if I did the times 10, this of course is still going to be 8x. That'll be 5 times 5 will be minus 25x. That'll be 5 times 2 will be minus 10. And 10 times 33 is 330. Here 10 times 33 is 330. So if we finish this out, this simplification process, 8x minus 25x minus 10 equals 30, 30. Okay, again, this is a minus 10, it's a minus 10. Okay, a lot of you are going to put the plus 10 there. So again, when it's subtracting a binomial numerator, either when you divide this 5, you're multiplying the entire numerator times this, that negative sign is being distributed through. Or, if you want to split apart the binomial numerator into separate fractions, it's minus the first thing, minus the second thing. That sign has to be a minus, and that'll get you the right signs there. Take your pick, you get the same result. What's left to do is to simplify and then solve. I'm going to move the 10 to this side. 8x minus 25x is negative 17x. 330 plus 10 is 340. We divide both sides by negative 17. Positive divided by negative is a negative. 34 divided by 17 is 2. And then add a 0, so negative 20 is the answer to that. Number 14, multiply. We're doing a binomial times a trinomial. And to do this, I simply multiply this times this entire expansion here. So 5x times x cubed makes 5x to the 4th. 5x times negative 3x makes negative 15x squared. Notice I left a gap because x cubed got skipped. Just in case x cubed shows up, I'm allowing space for it. 5x times 1 is plus 5x. So 5x times all three pieces creates this polynomial. Then I'm going to multiply positive 3 times all this stuff. Positive 3 times x cubed makes positive 3x cubed. Positive 3 times negative 3x makes negative 9x. Lining it up with my 5x. And 3 times 1 makes 3. Going that over all the way to the right. So descending order, 4th, 3rd, 2nd, 1st, 0 powers. And then finally add like terms. These are the only like terms. Everything else just comes on down. So 5x to the 4th plus 3x to the 3rd minus 15x squared. 5 minus 9 subtract because the signs are different. 9 is bigger, so it's negative. So minus 4x and then plus 3. Multiply all 6 multiplications. This times 3 things, this times 3 things, combine like terms. That's your answer. Majority of mistakes on these are carelessness more than anything, so just make sure that your products are coming out what they should. And again, add or subtract based on signs, not based on what you're looking at. So opposite signs tell me to subtract. If they were the same signs, I would have added. That type of stuff. Finally, number 15, find the distance between negative 2, 4 and negative 8, negative 4. So this says very clearly, find the distance. So they're asking not for an equation, but for a length. How far apart are those 2 points? And so far we've been using graph paper for this. I want to show you a technique without graph paper that you might prefer. Okay. Every time we use graph paper, we get a horizontal line representing our change in x. We get a vertical line representing our change in y. And the distance between the 2 points is this line right here, which is the hypotenuse. So that's what we're trying to create each time. And if I plot the points, and it doesn't really matter where the points are in relation to each other, but if I plot the points and I concern myself with these x's. So this is x and this is x. The simple question I have to ask to figure out the horizontal length here is how far apart are those two numbers? How far is it from negative 2 to negative 8? And the answer is 6 bases. And you can put negative 6 there if you really feel like it. I'm going to put just 6. I'll always put 6, so just a positive number. And if you're not sure how far apart they are, just think of temperature. If it's negative 8 degrees and it warms up to negative 2 degrees, it's 6 degrees warmer. The vertical distance, same idea. Negative 4 is one, positive 4 is the other. Those are the y values. Those are going to influence the height of this. And if I'm at negative 4 degrees and it goes up to positive 4 degrees, that's a total of 8 degrees warmer. So 6 is how far apart the x's are, 8 is how far apart the y's are, d is what we're looking for, and the Pythagorean theorem tells me that d squared is equal to 8 squared plus 6 squared, which means that d squared is equal to 100. So d is going to equal the square root of 100, better known as 10. If it comes out to like the square root of 7, leave it. That's fine. If it comes out to a nice pretty number like 10, square root of 100 is 10, square root of 25 is 5, square root of 441 is 21, whatever. If it comes out to a nice one like that, give me the exact answer. But if it comes out to some radical that doesn't simplify completely, feel free to leave it as a radical. But again, no graph paper necessary. I got all the information I need from the graph paper without using graph paper. You might like that technique a little better, a little simpler.